was a worldwide phenomenon. At its core sat an engine that broke every convention of its time. Simple, rugged, and mysterious, it earned a reputation few engines ever achieve. In this video, we uncover the shocking secrets behind Volkswagen's legendary air-cooled engine. It was inspired by aircraft engines. When most people think of Volkswagen's classic air-cooled engine, they picture the little beetle buzzing down the road. But what many don't realize is that this engine had its roots in aviation. Ferdinand Porsche, the man behind the Beetle's design, had studied aircraft engines from World War I, especially those that relied on air cooling instead of water. Airplanes couldn't afford the extra weight or complexity of radiators and coolant systems, so engineers had already mastered the art of keeping engines cool with nothing more than airflow and clever design. Porsche borrowed heavily from this concept. He took the same horizontally opposed cylinder layout used in many aircraft and applied it to Volkswagen's engine. The result was a lightweight, reliable motor that could run under extreme conditions, whether in blistering deserts or freezing mountain passes. This aircraft-inspired design meant fewer moving parts, easier maintenance, and incredible durability. It was overbuilt for a simple people's car, but that was the genius. By adapting airplane technology, Volkswagen created an engine that could literally go anywhere and survive almost anything. That's why it became legendary among drivers worldwide. No radiator, ever. Volkswagen's air-cooled engine broke all the rules by eliminating the radiator completely. Most cars relied on water-filled systems with hoses, pumps, and coolant to keep temperatures under control. But VW engineers designed a motor that stayed cool with nothing more than air and oil. Deep cooling fins were cast into the cylinders and heads, acting like heat sinks to draw heat away. A belt-driven fan forced air over those fins, while tin shrouds carefully directed the flow to every critical part of the engine. At the same time, circulating oil absorbed and carried heat from the inside out, giving the motor a dual-layer cooling system without a single drop of water. For drivers, this was more than clever engineering. It was freedom. There were no coolant leaks to fix, no frozen radiators in winter, and no need to carry extra water on long trips. Whether in the desert heat of Mexico or the icy winters of Canada, these engines kept running when others failed. The absence of a radiator wasn't just a simplification, it was a revolution. By removing one of the most common points of failure in traditional cars, Volkswagen created an engine that was lighter, tougher, and dependable almost anywhere in the world. Built to survive freezing cold, Volkswagen's air-cooled engine earned its reputation not only in deserts, but also in freezing winters. Unlike water-cooled cars, which relied on radiators filled with liquid, the VW engine had no coolant to freeze solid when temperatures dropped below zero. This made it especially reliable in places where harsh winters regularly disabled other vehicles. The design allowed the engine to start even in extreme cold, when water-cooled engines often cracked blocks or burst hoses. Its air-driven cooling system kept airflow steady regardless of temperature, and the oil circulation remained effective with the right viscosity for winter conditions. For drivers in northern Europe, Canada, and the northern United States, this feature was more than a convenience. It was a lifeline. Owners often recalled that while other cars struggled to start on icy mornings, their Beetle or bus would fire up and keep moving. It was rugged, dependable, and truly built to survive the cold. The engine block was magnesium. Few people realize that the heart of Volkswagen's air-cooled engine was built from an unusual material, magnesium. At a time when most engines relied on heavy cast iron, or later, aluminum, Volkswagen chose a magnesium alloy for the crankcase. The decision was bold. Magnesium made the engine significantly lighter, which improved fuel economy and handling. It also allowed Volkswagen to produce engines more cheaply and in greater numbers. But this lightweight miracle carried a hidden risk. Magnesium burns at extremely high temperatures, and once ignited, it is nearly impossible to extinguish with conventional fire equipment. In rare cases of severe engine fires, this meant the metal itself could feed the flames. The magnesium block became one of the features that set Volkswagen apart from its competitors, combining efficiency, durability, and a little-known secret that added to the legend of the air-cooled engine. Sounded like no other engine. The Volkswagen Air-Cooled Engine could be recognized by ear alone. Its flat-4 design and short exhaust system produced a rhythm unlike any other vehicle on the road. The cylinders fired in a distinctive opposing pattern, while the simple muffler gave the exhaust a sharp pulsing note. On top of that, the cooling fan and surrounding tin shrouds added their own mechanical whir, layering sound over sound until the engine developed its trademark character. This was not the smooth hum of modern engines, but a raw, mechanical voice that became part of Volkswagen's identity. Drivers quickly learned that you didn't need to see a beetle or a bus coming. You could hear it long before it appeared. Decades later, that unmistakable soundtrack remains a hallmark of the air-cooled era, and a reminder of just how unique the Volkswagen truly was. Overheating was a real risk. For all its strengths, the Volkswagen air-cooled engine carried one serious weakness: overheating. Because the motor relied entirely on airflow instead of liquid coolant, any disruption to that system could cause temperatures to rise dangerously. The engine's cooling fan, powered by a belt, was its lifeline. If the belt snapped, the flow of air stopped instantly, leaving the cylinders and heads without cooling. Equally important were the tin shrouds and flaps that directed air over the engine. If these parts were missing, damaged, or improperly installed, hot spots developed quickly. Even something as simple as debris blocking the cooling fins could lead to serious heat buildup. Oil also played a role in temperature control, and running low on oil or using the wrong grade could make overheating worse. In mild climates, most engines survived without trouble, but in heavy traffic, desert heat, or under sustained load, overheating remained a real risk. It was part of the routine of keeping an air-cooled engine alive, simple in design, but unforgiving if neglected, powered more than just beetles. The Volkswagen air-cooled engine is most often linked to the Beetle, but its story stretches far beyond that single car. This compact and reliable motor became the backbone of several Volkswagen models. The Type 2 transporter, better known as the VW bus, used the same flat-4 design, making it the engine that carried generations of families, campers, and counterculture travelers across the world. The stylish Karmann Ghia coupe also shared this power plant, proving the engine could serve not only a practical car, but a sporty design as well. Variations of the motor appeared in the Type 3 fastback and squareback, where it was cleverly mounted underneath the rear floor to increase cargo space. Beyond Volkswagen, the engine's influence reached even further. Porsche used an improved version in the early 356, giving the sports car its lightweight performance roots. And during wartime, air-cooled VWs powered military vehicles like the Kubelwagen and Schwimmwagen, prized for their durability in harsh conditions. From family wagons to sports cars and even battlefield machines, this single engine proved its unmatched versatility. Cooling fan was the true lifeline. At the center of Volkswagen's air-cooled design was a single component that determined everything: the cooling fan. Unlike water-cooled cars with radiators and pumps, the Beetle relied entirely on this belt-driven fan to keep temperatures under control. It forced air across the deep ends of the cylinders and heads, while metal shrouds carefully directed the flow to the hottest areas. If the fan belt snapped or the shrouds were missing, overheating could occur within minutes. For this reason, many owners carried spare belts in their glove box, knowing the fan was their engine's lifeline. Simple yet critical, it turned airflow into a dependable cooling system that worked in deserts, mountains, and freezing winters alike. Without that fan, the entire promise of Volkswagen's air-cooled reliability would collapse.